Hey, welcome back. So in the last lecture, we talked about the idea that for a reaction to occur, the molecules have to collide with a minimum energy called the activation energy. And we can represent this on an energy versus reaction coordinate diagram as follows. So we start off with the reactants with a particular energy, and as they bump into each other, their potential energy has to increase until they hit a point called the transition state, which is the maximum energy here, and then it decreases on the other side as they make products. There's actually a couple of possibilities here. The products can actually have a greater energy than the reactants, and vice versa. And if the products have a higher energy than the reactants, then we say that this is an endothermic chemical reaction. Delta H is positive. The reaction essentially absorbs energy as it proceeds. Whereas if the products have lower energy than the reactants, so if I go ahead and just sketch this other diagram over here, and there's my transition state. If my products actually have less energy than the reactants as the reaction proceeds, then it will end up giving off heat. So it will be an exothermic reaction, so delta H is negative. And again, the transition state is right here, and the difference in energy between being a reactant and forming the transition state is that activation energy or energy of activation. So I can draw that in on both diagrams. And so remember, the molecules have to collide with at least this energy in order to make it through and across the transition state into the product side. So here's a nice little video that kind of shows this reaction. So I'm going to take a fluoride ion here, and I'm going to have the fluoride basically react with this molecule here. It's going to form a bond here, and it's going to break a bond here. And as the reaction proceeds, we're going to plot the energy versus the reaction coordinate or the reaction program. So let's take a look at what happens.
When a fluoride ion approaches a methyl chloride molecule, a bond begins to form between the fluoride and the carbon. The molecule's carbon-chlorine bond lengthens and becomes weaker. The energy of the system increases. As the carbon-fluoride bond forms and the carbon-chlorine breaks, a configuration of maximum energy is reached, called the transition state. As the reaction proceeds to completion, the energy of the system decreases.
So that's a very nice video. So it kind of shows what's going on during a chemical reaction. So as we hit through the transition state, that was sort of the point of no return. So that was the highest energy. And as the chloride group left, then you lowered the energy until you formed products. So I wonder, right? So can you identify the activation energy and the heat of this reaction? And you can pause the video and maybe try and sketch out where it would be. Okay, so the activation energy, so this is the transition state right here, and the difference in energy between the reactants and the transition state, that's the energy of activation or the activation energy. And likewise, if we just keep going along down here, right, so this is the reaction energy, the reactants energy, sorry, and the products you can see are lower in energy. And so since it's lower, then that delta H must be negative. So energy is given out in the form of heat as this reaction takes place. Pretty cool, huh?